Okay. All right. So you say I'm Ben, and then I say I'm Alex, and then you say
This is our CS10 Final Project. So this is our CS10 Final Project, and it's a program called PathFinder, which solves mazes. So here on the main menu, you have Tutorial, Free Play, and Maps and Mazes. So Tutorial tells you how to play the game, and Free Play allows you to build your own mazes and then solve them. So you click on that, and you get a size selection bar that goes from 4x3 to 40x30. And you can drag the cursor around until you find the size you want, and then click. So after you do that, the program automatically draws in a grid of the size that you wanted, and then it asks you to draw in the walls of the maze by holding and dragging the mouse. So here we are drawing in our walls, and it's going to be a pretty simple maze for time's sake. And then when you're done, you hit space, and then you click for a green square, which is your starting position, and a red square, which is your finishing position, and then you hit go. And then the program goes through and tries to figure out every possible solution from the given point, and it moves on and works through every possible one. So here we sped it up because this took about 4 minutes to run on this maze. So for time's sake. And then once it finds the end, it just goes back and draws in the most optimal path back to the beginning.
So, this is the bulk of the code behind PathFinder. In this sprite, you'll find the code for drawing the grid, which is this big chunk of code right here, running the pathfinding algorithm, which is right here, labeled A star, and drawing the shortest path after the algorithm has ran, which is draw from path function. There's also a function for redoing a maze, right here, reconstruct, and another function for running a predetermined maze, save maze play, right here. So let's take a look at the actual drawing function for PathFinder. This big chunk of code right here actually draws the grid. It starts off by picking a starting point for the sprite and picks an X length and a Y length for the grid. This is the actual function that draws the grid, and it's probably the most important function. This function uses some math to actually go in and draw all the lines, but the important part is this record info for grid function, which actually goes in and makes a list of all the centers of all the boxes. So when the user actually goes in and tries to stamp new obstacles, it references to this list and stamps them in the correct spot. So this part right here is the actual stamping function that lets the user choose where he wants to stamp. So this stamp block type X at grid point X and Y actually lets the user go in and drag his mouse over the spot where he wants to stamp the obstacle. And this function will translate the mouse's position into the grid position and stamp the obstacle or the starting or end point at that spot. It will then change the block type in a list that stores all of the data for the grid. So when the function actually runs, it can easily access the points that are obstacles or an ending point or a starting point. Now, let's take a look at the actual brains of PathFinder. You'll find it right here in the A-star algorithm. Now, A-star is an algorithm that many game developers use, actually, including Blizzard for StarCraft and for Diablo and for some other games. A-star is a very complicated function and has a lot of nuances that I probably won't go over in this video, but you can always go to Wikipedia and look it up. This will just be a brief overview of how we use the function in our project. So, what A-star does is it picks a starting point, finds all of its neighbors, and then using a thing called a heuristic, which is basically an estimate of what the best path will be, it will choose the next point to go to and find all the neighbors of that point. It will continue to do this until it gets to the end, and then it'll run this function, reconstruct path, to actually reconstruct the path from the end to the beginning. So essentially, A star backtracks after it's found the end. This function is a little bit complicated and involves things like G-scores and F-scores, but the user doesn't really see any of this. Finally, let's take a look at how our algorithm actually reconstructs the path once it's found the end, using this handy function, reconstruct path. Now, this function actually isn't as complicated as it sounds. When the actual pathfinding function A star runs, what it does after it finds its neighbors and stuff like that, it'll go to the next spot on the grid and actually save its parent, which would be the green square if you moved away from it, and this will actually continue all the way until it reaches the end. So each point will save the parent before it, or whichever point it came from. So this function, reconstruct path, all it does is backtrack through all the parents and then draws a line through all of them. So again, for example, if I start at this square right here and I move to this square, then A star, this function, will actually save the parent of this square, which is this square, into a list. And then reconstruct path will go in after it's gotten to the end, will actually find all the parents of all the boxes before them, and draw the path back.
So in this part of the video, we're going to explain the maps and mazes section, which gives you a preset number of maps and mazes that you can try and solve on your own or have the computer solve them for you. So you click on it and you get 4 options here of varying complexity. So we are going to do the one on the bottom left. So once we click it, the program draws the graph and the maze, and then it starts to solve it. And it works just like a player-created maze, where it just goes through and tests all the possible solutions from any given point until it gets down to the end, where it will then stop and redraw the path back to the beginning. This took about 7 minutes to run on its own, so we sped it up a lot. But as you can see, it's finished, and here comes the path.